All right, I think we're live here. Um, if somebody's on the Discord server, can just give me a thumbs up on if y'all can hear me and everything, and we'll get started in 1 second. All right, thanks. Welcome everyone to the first, I guess, episode of this idea, Zero to Zero Day. So what I initially came to was this conclusion that I've learned a lot, not just in the technical piece of vulnerability research and reversing, but in more of the kind of knowledge you gain from doing it a lot, but most importantly, maybe from watching others. So I've been lucky enough to work with some really great reverse engineers, vulnerability researchers, exploit writers, and everybody works differently, but it's kind of great to see how everybody approaches these complex problems, gets started with an audit, how they manage IDA, just how they think. So that's really what this is about. This isn't this is certainly not scripted. This is not a CTF. Those are all great. This is really starting out from auditing complex software. We're going to go from the beginning. I've looked a little bit at this attack surface that we'll talk about, but I don't really have a lot of predefined ideas on what we're going to see. So this is really how a lot of this happens. So we're going to dive into it. We do have the Discord server up. There's a lot of people on there. I want to use this Discord panel. Unfortunately, Discord doesn't let me make this smaller, but I will probably look at this often, if not leave it up. If you have questions, if you want to, I'm going to share links in here as we go through it. The Discord server will kind of be the archive of all the work and all the references that we'll look at. And as you go through auditing, especially something large and complex, there's dozens of references that you need. It's so I'm going to put them all in there. One really kind of art of looking for vulnerabilities is finding your target. A lot of targets are pretty well understood. Let's take Flash as a target. It's usually understood, and it's usually we know that it's a ripe target because others have already found bugs there. There's been tons of exploits written, so it's known. But before you know something is kind of ripe or a target for vulnerabilities, you don't necessarily know that it's going to pan out. So you have to think about some criteria. And there's criteria when you look for vulnerabilities. Some of that criteria is it common? Is it commonly used? Is it exploitable? So does it have a lot of mitigations around it? Does it have a scripting language? Does it have all these things that you'll likely need when you write an exploit? And those all factor in, at least for me, when I pick a target, because I don't want to pick a target that everybody else has looked at. I don't want to pick a target that might have all the latest mitigations. And that's just me personally. I'm not that. I don't think I'm that brilliant at reversing and finding bugs. So I typically haven't had to bypass too many mitigations because I think about it before I pick the target. So then another one, as security grows, certain targets become a lot harder. So we're seeing that with browsers. Browsers used to be fairly easy. You had complete control of memory through JavaScript, a lot of plug-in attack surface, all these things that as an exploit writer are fantastic. Well, those start getting locked down, especially since everything is in the browser now. Those become harder. They're sandboxed. You need 5 bugs. And so the targets change. And the exciting part for me is finding new targets and finding targets that might not have that same attention, because I like to explore new software. When I'm reversing, I like to to do something new. I've done some hardware stuff, and that's always kind of fun. So it's a personal preference. Again, there's fantastic people that are just have really honed in on Flash or on Chrome or on Linux kernel, and that's their wheelhouse, and that's awesome, and they're brilliant at it. Everybody's different, and so I think what I want to encourage with this is embrace how you're different, and embrace what you enjoy, and embrace what interests you, because there is not necessarily success at the end. It's not planned out. You have to enjoy the process. If you don't enjoy the process, then sludging through a 20 meg binary in IDA is going to suck after a while. So that's what I'll show you, is just my process. And again, questions. When I was at Tipping Point and we were on the ZDI team, and Pedram had Open RCE, there was a fantastic community, and that's one thing I've liked about vulnerability research, and maybe reverse engineering more so. I've never met a good reverser who hasn't been completely destroyed by some kind of complicated binary or obfuscation or something. So it's really humbling, and there's not a lot of egos if you do it a lot, because you've gotten your ass kicked so many times. So I also want to kind of build that here too. So ideas, whatever, put it into the Discord channel, and we'll check back. But let's just kick it off. I think just some other things. I'm going to try to keep this to an hour every week. Normally I would have 12 hours a day to do this, and that's likely what it takes to be really successful, is having that mental focus to go for a long time. Maybe do a couple 12-hour days, take a break, and keep going. So unfortunately, I'm not reversing and finding bugs as my day job anymore. I'm really enjoying kind of taking a step back and working on other things, but as a hobby, I still love it. So I was going to do this anyway, so now I'm doing it with y'all. We'll see how far we get. Again, I'm going to reiterate this over and over. I don't know if I will find a bug. I might not. We might find one in a month. We might never find one, or in 2 years. I don't really care about that. So it's about the process. Obviously, as an entertaining stream, I want to find that bug with you guys, but we'll see. You never know. I think one thing that I've always told people that are new to it, as soon as you stop looking, when you quit is when you were about to be successful. So a lot of determination goes into finding bugs, and really there's no magic to it. So I will stop rambling and start showing how little magic there is. It's a lot of hard work, and it's a lot of trial and error, and fucking up, and not knowing, and naming functions I don't understand, and all of that gory stuff. We're going to look at it. I'm going to be wrong, but whatever. So let's talk about the target that I came up with. What I have right here is an NVIDIA GPU. This is an old one. I think it's like a 7 series GeForce. I took the heat sink off so you can actually see the nice little NVIDIA processor there, some memory, all those kind of things. What I've realized about GPUs is they're becoming less of a parallel graphics processor and more of a general computing architecture. And if I take a step back, general computing is something like your Intel processor. You can compile code for it. It'll run on the processor. It doesn't take a lot of specific hardware level implementation knowledge, and writing hello world will run. GPUs, on the other hand, have historically been highly parallel. So instead of just being 4 cores in here, there's thousands of cores. And the power of the GPU is that the code you write actually runs on all of those cores in parallel. So when you write parallel code, it's different than writing general purpose code, because you have to be able to write things that can be broken up into parallel chunks and optimized enough to work on this type of platform. Now, a couple of advancements that I think everybody really understands is that we're using GPUs for something besides just video and games and things like that. So we have deep learning, we have the machine learning, we're doing crypto mining, obviously has been really popular, but people are starting to use these more as a general purpose platform. Where that's, I think, interesting is anything that's built for one type of architecture and tries to make the move to a different kind of computing architecture is not necessarily going to be going to have the same security built into it, or even the maturity of being a general purpose processor like an Intel. Over the years, being used as a general purpose architecture has learned to build in some security. So as these GPUs move into more of a general purpose architecture, the attack surface goes up. And so that attack surface becomes really interesting, I think, from a vulnerability research perspective. So you can write code for these things, you can upload code to these things. There's a lot behind the scenes, and one kind of side benefit from an attacker and an exploit writer is even in a virtual environment like on AWS, if you provision an AWS deep learning instance, it has a PCI pass-through straight to the GPU. So any hypervisor level security, any OS security, anything that is, you know, security through privilege is going to now kind of be more difficult because these are directly connected to a system that you can easily provision, easily get root on, and then have access to the PCI device. So we'll look at some of that. We'll also look at whatever we think is interesting. For right now, my intention is to start off with just how this GPU is exposed inside of Windows 10, and what the GPU can do as far as code and input from a user. We'll see how that might break down. We may look at how VMware has a driver for the GPU. I don't know. We're going to get started and just kick it off from that. So before we do that, on Discord, there's one question: what size binary is considered too large to reverse? I think above, it depends on what you call reverse. So for vulnerability research, you don't need to reverse the whole thing. You're not trying to re-implement something a lot of times, so you can probably take on more. It would be really hard to reverse something that was probably 5 megs without some kind of debugger or some kind of assistance. But once you go above that, you're not looking at taking a binary and reversing the whole thing. You could think of this as like a problem explosion kind of situation where you're never going to take any kind of software and just figure it all out and then a bug is going to show up in your head. You've really got to look at the features of that software, specific attack surfaces, and try to drill down into just that section of the DLL or the different DLLs. And so I'll show you kind of how we go through that. Yeah, so you know, if I was going to reverse something full on, I don't know. I mean, it's just a matter of time, but I wouldn't do something that's too big. It wouldn't be fun after a while. But we'll see how we kind of make those decisions. You know, I think a good one, if you've ever looked at Flash, a good one that people do is, you know, they'll look at like ActionScript, right? So ActionScript is just a small part of the Flash plugin. The rest of the Flash plugin has GUI interfaces, networking interfaces, audio decoding interfaces, all these things. So you might want to just say, I'm looking at ActionScript, and then figure out how to enumerate the ActionScript code within the 20-something meg Flash plugin. And So people do that. They'll find the V tables for different action step classes and then go through all that. So, that's just kind of a anecdotal way that some people have done it. But again, everybody has their own different way. This is just how I approach it. So if anybody's on Discord and my windows are kind of hard to see, I'll try my best. All this is recorded and I can go back through it at some point. But so the first thing that we have to kind of conceptualize is what exactly is the GPU. Okay, we know it's hardware. I'm not going to look at any of the hardware on here. I'm just going to look at software. So a GPU is a device. And an operating system, in order to talk to this device, has to have some kind of interface, some kind of software to hardware interface. That's almost always a driver. I don't really know another way you could do it, but so I know the GPU has a driver. I know that NVIDIA has a driver. You talk to it from user space, and that driver is responsible for taking input and then communicating to the actual hardware over I/O or PCI I/O. I also know that the GPU has to map memory, so it has its own memory. I know that it also has probably shared memory with the operating system because it needs to be really fast. So it has to be able to map some kind of physical RAM so that the kernel or user land can talk to the GPU. I have a little bit of graphics programming experience. I'm by no means an expert, and I welcome any experts to hop on and help out here if we need to write some code or something. But I know that there's a frame buffer. So a frame buffer is just painting the screen. And I think there's some memory management behind that so that you're always, if you're playing a game at 120 frames per second, then this thing is writing directly to different frame buffers, and it's just going as fast as possible to try to do that. I think that's part of the fun of the complexity that we'll see, or maybe it's complex. I can only assume it is. And again, as these things become more general purpose, I think there's always a balance between security and usability. At some point, NVIDIA cares more about frame rates for gamers than they do about security, and so we'll try to see if we can figure out places where that can be broken. All right, so we know there's a driver. To figure out a driver, sorry, I'll get rid of that. To figure out a driver, and I'm making a couple of different directories here. As I set up for a project, I usually create some things like a data directory, a tools directory. I'm going to figure out how to use GitHub to manage this repository as we go through it. I did write a tool that we'll try to use that hopefully I can use instead of sending IDBs. So if you've ever worked in a team, your IDBs out of IDA can be huge. Some people have done good things with Collaborate. I think CrowdStrike released one. So I'm not going to use any of that kind of stuff. But either way, I can't put IDBs in a GitHub. So we'll have to figure something else out. And then I have some tools. So I try to keep a lot of this in the same directory. If it's tools I use all the time, I'll just make a directory on my local system. But for this purpose, I might check some of this in. I might not. So let's just talk about tools real quick. I don't use a lot of non-basic tools. I use IDA. For this one, I'm using the free version. So anybody, if you check Discord, I pinned it. Anybody that is following along can just download free IDA. It only works on x64 PE, which is convenient for us. I noticed there's no Python, IDA Python. So I've actually been writing some IDC lately. I think you probably could install IDA Python and still use it, but I'm just going defaults so that anybody that follows along doesn't need Pro or IDA Advanced or Hexrays or anything like that. Unfortunately, I don't even have licenses for that anymore since I don't do it day in and day out. But you know, this works just as well. So we have IDA. I use on Windows 10. I use the Windows subsystem for Linux a lot. I actually like this. This is where I'll do any Git stuff. You know, I might do some tools over here, but I really like Ubuntu. If you just go to the Windows Store, you can install Ubuntu, and that works really well. WinDebug. This is the new WinDebug. If you haven't seen this, this is the Windows Store version, and it's got the Microsoft Word type ribbon, which is kind of weird, but I'm going to try to use this, just see what happens. Really, I started using OllyDebug. I think I used it for like a year. I don't recommend it. I really recommend that if you can learn to use WinDebug. Not only is it, I mean, there's a steep learning curve, but the features that it has just blow anything else out of the water, in my opinion. If we have to do kernel debugging, this is the only way to do it. The symbol support is really good. You know, we'll use a symbol server for Windows binaries, and I haven't used OllyDebug or Immunity Debugger in probably 10 years. I really suggest trying WinDebug. I don't really use. I try not to sit in the debugger too much, so we probably hopefully won't be using it a ton. But if you are using WinDebug, here's how you set up your symbol server. This is just an environment variable that you can set, and NT symbol path right here. That'll store to my local symbol store anytime I load up, and then if it's not found here, you can see I already have a few, then it'll reach out to the symbol server and dynamically download that. Unfortunately, we don't have symbols for NVIDIA stuff, so we'll have a real reversing challenge there, but all the other Microsoft stuff will hopefully have symbols for. Without symbols, you're just going to have to spend a whole lot of time for really no reason. And so anyways, that's WinDebug. We'll see if we like this ribbon. I think it's a little bit cheesy for a debugger, but I don't know. Microsoft's kind of going to put ribbons on everything. So I'll probably fumble around a little bit there. What else do we have? Let's see. I use Visual Studio Code. I've really started using this a lot. I really like it, especially for C. It's got IntelliSense built in. It's nice, got some formatting and a lot of that. So that's my text editor. And over here in this window is Process Hacker. If you've ever used Process Hacker, it's basically like sysinternal's Process Explorer, except it's got some different features. I mean, it's not that different, but it has a little bit more. If you start looking at services, you start looking at kernel stuff, it's got just a little more to it. It's also open source. So if you ever want to know how tokens work, or you want to know how devices work, or you want to know some of the underlying Windows internal stuff, go read the source. It's really good. It's easy to read, and I recommend checking it out. So we'll use this. It also has plugins. Conveniently enough, it has, I thought, it has a NVIDIA driver plugin. We'll figure that out. But Process Hacker is great. I think it's still like on SourceForge. Yeah, so you can get it here. I really need to, it has to have a GitHub by now. But anyways, you'll find it. No, that's just, it's somewhere here, but good code. The other one I use is WinObjectDX. This is kind of another enhancement off of the sysinternal's WinObj. This just gives us kind of, it's like a directory listing of all your Windows kernel interfaces and handles, all those kind of things that we may need. We might not need it, but we'll see. Since we're looking at a driver first, we're going to be going back and forth and just trying to enumerate all the different software components that allow us to talk to the GPU. So first things first, let's go back and look at Process Hacker. Let me view the let me look at the sorry, it's been a while. I'm a little bit rusty, so it's going to take a little bit of time for me to remember some of this stuff. But we'll look at, let's see if we can just get properties here. So this is the system process, which is basically like, and again, I'm no Alex Ionescu, but so I could be wrong on some of the terminology. I'll do my best. But the system process is kind of like the userland pseudo representation of some of what the kernel is doing. So we can see inside of the system process, none of this really makes sense except for your modules. So your modules are going to be your drivers that are loaded. One of the good things that you can just do is go through here. You can sort. So looks like, yeah, that's sort is fine. So we see that there's actually two drivers that are loaded. There's an NVIDIA HDMI audio driver. There's an NVIDIA Windows kernel mode driver. I'm just going to assume that we don't care about the audio driver yet. I'm worried about GPUs and video. So this is probably the big driver that handles most of the I/O and the iOctals and stuff like that. Never underestimate the properties window on a DLL. It has a lot of information. We can see it's signed. So a lot of these things you kind of, everything's signed now, but before that might have been interesting. The details right here are always good. We can see version, we can see it's a kernel mode driver. And so this looks like a pretty good place to start. And it actually has an interesting path that I'm not really used to. But here's all the other drivers that are loaded. Let's just look and see if there's anything else display related. So I want to know, if, the whole time you're gathering information. So you're trying to learn how this might work at the highest level. I'm not going to jump into anything right now. This is super high level. We're just trying to figure out how this is maybe architected. We'll use Google in a second to try to get some information. But I want to kind of start out from at least a few locations on disk and what I can kind of think of myself. So you always want to formulate your own ideas and then try to go fill in gaps. You don't want to just read what everybody else has done because you may have information they don't. You may think differently. You always want to use other people's work as complementary and to cover any areas that you don't have time to look at. So let's just grab this path that I got. This is a different kind of driver store, but we can see that this is obviously where the NVIDIA drivers install to, or at least one of the locations. So this has a ton of DLLs. And you can see, as we look through, we've got a JIT compiler, we've got some JSON, OpenCL. We're going to look at all this. Again, don't be afraid. Never underestimate right-clicking and going to properties, because we can see that this is actually not written by NVIDIA. It's written by Kronos, OpenCL, ICD. Always great to find third-party DLLs, not necessarily because they're buggy or they suck, but because this might give you the information that NVIDIA doesn't want to give you. So we kind of keep a log of this in our head as we kind of go through. I'll just start to pull some of these into my data project directory. I try to not grab all of it. I try to be more strategic just so I don't overwhelm myself. I get overwhelmed really easily with just information overload. I don't know if I have ADD or what, but it's a lot to take in. So if you have that problem, just go slow and take it a little at a time. If you want to just grab it all and try to work through it, that's cool too. I see a CUDA DLL. So CUDA is NVIDIA's language for writing compute software. So this is what you use for like crypto mining or rendering. If you have like if you're into 3D stuff and you want to render, they might do that through CUDA. As a hobby, I kind of do some 3D art and rendering and stuff like that, where I actually kind of got some of this information from. We have another compiler, so a lot of cool stuff. We have an API. This to me is fun. This is telling me that there is so much to cover. It would probably take me a long time, but maybe others want to jump in and start looking at some other things. So let's just stay on track with our driver. I will grab this. Always cut and paste. Never try to drag them out of here. I'm going to remember some of this, but let's look at this driver in IDA just to get a sense of what it might do. I'm not looking to reverse again. I'm looking to just get started. So what else might be interesting? Let's pull it up in IDA. Let's get going. A few things from my IDA that I may do differently. I don't use a lot of GraphView. If I use GraphView, it's just to learn the control flow. I'll probably use GraphView a lot in the exploratory phase, but once I know what I want to reverse, I like to just go linearly through and try to build up an understanding of the function. And the parts about the function that I care about are the local data storage, pointers, structures, classes, a lot of the control flow. Sometimes I'm less concerned about in the beginning, but we can use GraphView to just kind of toggle on and off, just to try to figure out, like, make sense of simple stuff. So let's see, what else do I do in IDA? Sometimes I will use the notepad on the right, and I'll dock that to the right. I might use the notepad to keep track of just some local function information. So if I want to know something is right here, I might put it over here. So I'll use the notepad. The good thing about the notepad is it actually saves to your database. So if you want to use this a whole lot and you save your database, it'll stay there. The downside to the notepad is the formatting sucks. So if you do anything that wraps or whatever, then it's really hard to tell. So we've got a driver. So this is going to take a bit. We'll explore a little bit. I'll show y'all a few things once this gets going. Let's just pop over and see if someone has questions. Nope. We can probably start with just looking at some imports. While this disassembles, I'll look at imports. Everything is going to have imports. This isn't malware reversing where they smash imports or they dynamically resolve all imports. So in a driver, really driver code is easier to reverse than anything because Microsoft requires you to follow a very strict kind of development process. They got tired of all these shitty blue screens. So in order to get hardware certified, you have to actually upload it. They make sure that it's kind of like the App Store. They make sure that you're following the right software development practices. You know, they give you all this additional code to fuzz your driver, to test it. And so it's going to have a lot of the same kernel imports, and it's going to do things. This driver is going to do things very similar, at least the basics, very similar to any driver. So I would recommend if anybody hasn't looked at drivers yet, to go do it. Write a few drivers on your own. The Microsoft DDK actually includes a ton of really good sample drivers and sample code for almost every subsystem in Windows. And I bet, and I don't know if I have the DDK installed here, I bet there's a some kind of graphics direct 3D driver sample that will show you how a developer might take the sample and start writing production code. And don't be fooled. A lot of driver developers that are writing production code are looking at MSDN, are copy and pasting, are looking at driver samples, and so you'll see a lot of that repeated. Microsoft has also open sourced their like a part of their kernel. I don't know how comprehensive it is, but it's at least some of the NT implementation, and so you can go look at GitHub on the kernel source. And you know, if you're confused, just kind of go poke around there. Let's look at that, see if I think I can just find it real quick. Microsoft student student kernel. I know it's here somewhere. Let's just look for Microsoft open source kernel. Maybe it got leaked. Oh, maybe it got leaked and I wasn't supposed to see it. I don't know, but it's out there on the internet. I'll find a link and post it in when I can find it. The reason that I don't think it's such a big deal is because I think you just have to be an academic institution and sign a paper, and then they give you the source code and you can look through it there. So it's out there. There's also React OS, you know, the brilliant kind of kernel reversing effort that always you should look at if you need some information. Not only is it kind of a lesson in just the Windows internals, but just in the reversing that went into it. So that's a good project to look at. It's been a long time since I've looked at this, so I don't know. I don't know if it's on GitHub or whatever. I'm sure if y'all watching are going to be shouting at me if y'all know where locations are, but this is part of the fun, just watching someone fuck around here. But why do people still use SourceForge? Oh my gosh. To sell books. I know this is on GitHub. I'm like 0 for 2 on finding GitHub links. Yeah, alright. Now I've downloaded the source, but whatever. I won't get too sidetracked. Normally I would get sidetracked, but I'm trying to stay focused. So, Ida beeped at us. We know that almost anything reverse is going to have at least a single export, main, start, DLL main, whatever. So we'll just jump there. But let's look at our functions that this driver calls. What I'm looking for is not necessarily to just. I know I've done some kernel development, so it's not all foreign to me. For instance, you know, there's going to be a lot in a kernel of synchronization. A lot of timers. So all of this stuff here is from set event to acquire is just synchronization code. It's not that interesting. One good thing also, all the memory accesses are going to be tagged. I'll show you that in a second. So it's a lot easier to find memory locations. Let me just sort. This will be easier to see what I'm talking about. So acquire will be your mutexes. Allocate pool. We'll look at this one. This one's basically the malloc of the kernel, which is always going to be great for bug hunting if you want to find some, you know, integer related or heap problems or pool problems. And not interesting. Register callback is going to be interesting in the kernel. A driver can register for all kinds of callbacks, from file system to network to whatever. Registry, process, anything. So callbacks are great to look at. If Caducity thinks this is he linked in the channel of the research kernel. Yeah, that's exactly what I was thinking of. So, you know, all this is not that interesting. Callback's going to be interesting. Allocating memory will be interesting. There should be some physical memory stuff. Create device. Everything will create a device object. Let's see if we've got some I/O. I/O, no. Here's some I/O get device interfaces. I'm not really sure what those do, but I know that if we're expecting this thing to perform some kind of I/O level stuff, then we'll likely see that somewhere. More mutexes, timers. Go read MSDN if you don't know what stuff is. For the kernel stuff, it's very well documented. So you're unlikely to see any commercial driver that is not is doing something undocumented, like in the past. Sorry, I'm going to turn my light off. In the past, you might have seen like some pretty weird, I don't know, some weird calling, I/O calling or system calls or whatever, and typically they don't do that. Microsoft gets pretty mad if you do things that are undocumented because it's going to cause a blue screen at some point when they change the ABI here. So let's keep looking. This again, we're building a profile in our head. We're not trying to understand everything in the world. I'm looking for clues, really. I'm looking for clues that tell me this is interesting, and interesting changes based on the time of day. So here's some physical memory. I'll show you what some of this is in a second. Right here, map IO space, I think is one of the good ones. Is that it? Yeah. Yep. So this is going to give physical address ranges to non-page system space. So things like this, I expected the driver to do. I'm not going to really look at this right now, but we can see that we know it's going to create a device. We know it's going to map some physical addresses, which is physical memory. It's going to look for some pages. That all kind of makes sense, or at least slightly confirms the intuition there. When you map hardware, you have to lock it. You have to lock pages in the kernel. So that's all pretty interesting. Some power callbacks. Probe for read and write. Probe for read and write in the kernel is just checking for the address to be, a canonical address or to be safe for the kernel to touch it. So you'll see this if something's going to touch a user land pointer or grab user memory. So if you look at a kernel function that you have access to and it doesn't do probe for reads and probe for writes, that might be a good place to look for a bug. If they do, that might still be a good place to look, but really it's all about looking through this and trying to find the path of least resistance. Or if it is a resistant path, you better love it because it may be very difficult. What else are we doing? We've got some pretty boilerplate stuff. Registry keys, DACLs. This is something that every driver is going to do. SIDs and security descriptors, which after 20 years I still struggle with. Blah, blah, blah. Nothing that interesting. Load driver, some open files. Query system information is always pretty good to look at. Okay. So there's nothing that jumps out right here that may be, I don't know, that significant, I guess. I think what we know is it's going to create a device. So we'll just kind of look at that. And let's see if I can. I'll go back. I can go backwards. I can go forwards, but we should see, like, I use Control P a lot. Control P will take you to the top of the function, and then Control X. So basically, I went kind of backwards, but the start location inside of a driver is this is generated by the compiler, but you implement a driver entry function or driver main function, and this is a function where you'll do everything that Microsoft wants you to do to tell the system you're a driver. You can load, and you pass it in a lot of different callbacks in a big structure, and anytime whatever you've registered for, the driver chain will call you and then call the next one. So if you register for, if you're a file system driver, you'll be put in the driver stack for file system drivers, and you call it down. So you've got to do a lot of setup in your driver main before you start executing your code. So we can look at driver main, and you'll see on my left side, I'll make the kind of this left side, I don't really need the function view. So this is the full driver main. I'm assuming, because one thing I do know about driver main is that if you fail, you have to return a failure code. So I'm going to assume that any failure is probably going to go this left branch. And we'll see on this side. This actually, I forget, if you click, it'll take your window. So this left side is likely the failure case. So we'll see jump 0 tells me that we're looking like the positive case. The true case is actually returning 0 from these functions. That's likely what Microsoft has you do, and anything that's non-zero or negative is some kind of error code. You can check that by, this is why I don't like GraphView. So this is the error code. Right here they're setting assigned integer. And yeah, so one good thing, if you're on a constant that IDA knows about, and off the top of my head I forgot how they have these symbolic constants. I know there's a lot of kind of supporting metadata files that IDA will have that has a lot of this information. But you can right click and you can go to use a symbolic constant, use a standard symbolic constant. So we can see that this is status not supported, and it's from the NTDDK. So I think that probably matches up. Sometimes these are accurate, sometimes these are not accurate. Sometimes it doesn't matter. Having a label that is English or human readable is better than not. So the assumption that we kind of looked at here is that this case that we saw is in fact going to be an error. You can see status not supported. So the right side is good setup, left side's bad. I said I was going to keep this an hour. We may go over a little bit longer. I guess it's a good stopping point maybe to do more than just explain what may be obvious to some of y'all. As I look through this, I don't know, you're not going to know what all this is. And I'm not going to necessarily dig in to all this right now. This is why I do not like, let me, trying to think of the best way to display this for y'all without jumping around everywhere. You can go into these functions and you can look. Not going to tell you a whole lot right off the bat. You can start. I'll start to show y'all how to label. I try to stick to a labeling scheme that's more like how I would write C, but they're just setting up a ton of global values. This is all in the data section, so it's read write, and we have, what's nice here is we have the size, so we know there's some byte fields, we know there's some D-word flags. Again, as a human, I can't tell you right off the bat what this is doing. This may be interesting, may not be. Initializing those mutexes. So again, a mutex is synchronization. I could label these, and I'll do that for some of the binaries, but IDA does a pretty good job of some of that. One thing to note here, this is calling EX allocate pool with tag. So one good thing with any of the tag functions is it's going to allocate with a pool ID, and this is actually in the wrong Indian order, so it's NVLH, which means it's some NVIDIA something. So I think right now we're just looking through, I'm just trying to figure out what the driver might be doing that's different than what boilerplate drivers do. So I think I'm seeing a lot of zero initialization. Nope, it's a function. So this is some kind of function, and I bet we're seeing a lot of this. Okay, so this is interesting. We're seeing right here a pattern. This pattern is setting up function pointers. So we have a ton of function pointers. You see it loads it into RAX and stores it. Loads it into RAX and stores it. And these are all different. So these are interesting. I might come back through and I might label these. So let's say, I'll show y'all something I do right here. You're probably not going to see this called by itself a ton. Yes, so you don't see this function called. The only reference to it you see is actually in that driver entry. But this is probably called often. And that's interesting. That's different. So as a function pointer, I would expect something to call that more often. Let's just check some of these. They all go through a trampoline. Okay, not a problem. A different pattern, but patterns are good. You want to find patterns. You don't want to get hung up on trying to like overthink the engineering side of it. So I don't know what it is, but it's something interesting because I know that all of these are proprietary code. So this is where the meat of the implementation might be. But what I was going to show y'all is, so this is loaded into RAX and RAX is stored here. So this is our function pointer. I can do this as a repeatable comment. And then, so you do a repeatable comment by just doing the semicolon. Shift semicolon is going to be just a comment. The power of the repeatable comment is that every time you see this, you now have the pointer that it points to. So by doing that, if somebody calls this, or, let's say we look at this cross-reference. So I don't know, there's no way that I know of an IDA to like change this to actually show you what the pointer has. But if you do a repeatable comment, then anytime that is referenced, you can jump to the function. So that's really helpful, especially when you have these function pointers everywhere. So at some point in the future, I might go through, maybe I won't bore y'all, but I might go through and add a comment to all these. It just depends on if I'm going to spend my time in this driver or I'm going to spend my time in a different DLL. I don't want to over optimize early, but I still want to know how this driver works. So some of the basic question is, does this have a large attack surface? I know that it's 16 megs. I know that it does stuff to the GPU, and I want to hack the GPU, so this may be my interface. All different pool types. Another one you might do is like, especially if it's allocating memory, you might want to just call this one like EX allocate pool with tag W as like wrapper. And then next time you see this, you know that it's going to call the pool. You can see how many times this is cross-referenced, 664. So instead of having to really keep track of it, you might want to do these wrappers. All right, well, see, our wrapper's now showing up. You can see this is another global variable. Here's another hint. If you're at a global variable reference like this, you don't really care about the, if you're trying to understand what this is, you don't care about the read, you care about the write. So you can sort this by type and go down to the writes. So if you want to see what the value is, you can kind of get a better sense of it by looking at the writes. And I bet, so RAX has some kind of value. Anyways, another tip. Mset, blah, blah, blah. Register bug checks in case you blue screen. Okay, blah, 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 don't care. I'm not gonna reverse all this. Let's look at our exports. So export in the driver can mean maybe another driver calls it. Maybe you know, something else, some callback needs this exported. Here's dump config. That could be kind of interesting, although I'm not. Maybe that's not necessarily a function exported. I don't know. I don't know what that is. This looks like this is a string, but it's not, it's a Unicode string. So if you go edit, I think it's, let's see, what is it? Edit strings Unicode. If you go edit strings Unicode, it'll fix this for you. At some point I had a hotkey, but no longer do I have a hotkey. I know there's a better way to do this, but I'm just trying to show y'all that sometimes it doesn't tell you that there's a Unicode one, but there is a Unicode one. And it's UTF-16, so that's Microsoft's Unicode. So some stuff here. We can actually just look at strings if we're going to mess around with that. I think it's F11. No, Shift F12 pulls up strings. Don't let anybody tell you that strings isn't proper reversing. This is, again, we're just humans, man. I don't know how to read all this crap, so this is chugging along. One thing that's really, really important, when you open your strings window, go to setup and make sure you have this turned on. Make sure you have Unicode C style turned on. Otherwise, you're going to miss a ton of strings, especially if they're Unicode. So have these two checked. Min string length 5 is fine. If you get a lot of junk, then you can do something different. Let us go. All right. If you sort by address, you'll probably get a better sense of a grouping. So in code, the compiler is going to compile out basically kind of linear how it finds it. So if you want to know, like if you see a grouping, that's probably how it looked in the source file. It was grouped in some way. If you don't care about order and you just want to go with name, like the sorting of the ASCII, then do it this way. Sort this way. We're not looking to know anything except what some of this is because we want to get excited. That looks like WinDebug commands. No? That's interesting. That's fun. Some kind of XML in here. I like that. blah, 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 blah. There's a lot of strings in here. Don't care about junk. I'm looking for those. I'm looking for something that gets me excited. So XML gets me excited. That sounds really strange and maybe sad that I get excited about seeing XML in a driver, but whatever. To each their own. Blah, blah, blah. Let me sort, since I'm not really, like there's a lot here, I'm going to go back to that grouping. See how if now I switch to grouping and that junk is at the top, that's because IDA thinks it's a string and it's not. So we go about halfway down. What do we get? What do we get? Oh man. I don't know what, I don't want to like go through all this. Now this is cool. Let's get to the top of this. Oh, this is fun. So we know that there's some kind of constant, maybe a define or an enumeration or something like that, where they've got some client stuff, some SRAM. It's not popping out. I do know that these drivers have, or that the GPUs have all kinds of different languages that they understand. So they understand shader languages, they understand all kinds of graphics programming stuff that I don't really understand. But so a lot of this could be related. It's fun. Back to junk. What do we got here? Registry. This is probably some kind of GUID. Come on, what's cool? What's cool? I always like looking at these, just makes me feel like I'm with the developer when they developed it. So I like to see how they like, this is dumb, but man, I like to see how people like keep their stuff organized. So at NVIDIA, I can imagine it's a huge team, and whoever's building this, they have a tree like this, so it's kind of fun to see. I got into reversing because it's like a puzzle. It's like you just don't know what you're going to see. And a lot of times nobody ever expected you to look at it. All right. I'm looking for something to pivot off of, so I might not stick with this. But I sometimes will take something I find here and look at Google and just see if somebody else. What's great about like GitHub and stuff is that people have started to, they're just all the code's up there. So if somebody has done something with CUDA or graphics programming or something, they might have code out there that I'll use. So here's a great example. I know that shader programs are something that you can write and upload to the GPU. When you write an exploit, you typically these days you need some kind of way to leak memories or read and write memory, upload code, have some flexibility. A programming language gives you that. I know that a shader language can give you that. So seeing stuff like this is a good lead, because this tells me that there was an exception. The shader program, so if we wanted to fuzz shader programs, the header here caused an error. So this function I might call like shader program error. And I might mark that. So Alt-M will mark that. And we have a big class, probably not a class in the kernel, but a structure of function pointers. So this is shader program error. Maybe this one, if I was to guess, this might be about shader errors. Nope, that's some kind of function pointer. So other ones don't have that same error, but this is certainly interesting because we have one clue that there's a function in here that is responsible for loading a shader program, and it does not, and it's in a big structure with other functions. So these may be all shader related functions. So I might call these shader callbacks. I bet if we followed this, there's something in, well, there is our pointer right there. So there's something in our setup that probably initialized this. I know it looks chaotic. All I'm trying to do is figure out where more of these functions might be. So right here, this is a group of certain types of function pointers. And like I said, when the compiler compiles these, it puts them in order. So usually, like at least in unit order. So a compiler takes each file, that's like a unit, and it compiles it into code, and then when it links it all together, it takes each object and it puts it together. Typically, the orders inside of each source code is preserved. So if this is some big some implementation in a C file, these are all related, just usually by the way that people organize. Okay, so we've got some big chunks. If you don't know shortcuts in IDA, escape, we'll go back, control and enter. We'll go from the previous location. So you can go back and forth this way really easy. And then enter follows it. So see how I go back? Okay, let's go back. We won't get too off track. The reason I'm not getting too off track is because I know that if I go to shader callbacks, I've marked it with Alt-M, then I can find my way back. So let's back to strings. All right. See, we're getting a lot of information. Uncorrectable error correcting memory detected on a GPU. That's all cool stuff. More exceptions, blah, blah, blah. I don't really know. Stack load. All this is interesting. At some point, we might write a fuzzer. Really, really far off, but like I probably wouldn't take the shader attack surface and try to, try to reverse it all, because I bet that it's either the shader is compiled in the kernel or in userland and pushed down, or there's something on the GPU that does it. I certainly don't have the skills to look at the actual firmware for this, but another open question in our head. Okay, we're getting at the hour mark. I'm gonna try to keep this to an hour, but like all good reversing projects, you just kind of see that you want to keep going. You want to keep finding stuff. So here's grid. Grid is like I think grid is like a protocol or some kind of hardware that NVIDIA has, API stuff, and more. So Pascal is the architecture, is the NVIDIA architecture. They have a Pascal architecture and a Kepler architecture. So they've got some kind of architecture-dependent linking of files, and this is just left in from whatever. But all hints, all hints. We might be able to find some links to that. Some of this could just be linked in from other libraries. It might not be that interesting. You have to balance between between different aspects. So again, back to kind of the question about, am I going to reverse this whole thing? No. I'm going to find the section that deals with what I care about. If that turns out to be shader stuff, I'm just going to find stuff that deals with shaders. I'm not going to look at all this others, because you'll just get distracted. Okay, so we're starting to see some DLLs, which is cool. And OpenGL user mode drivers, OpenGL drivers, And this might be where we pull in some of these others. So we have a shim, user mode, UMD probably stands for user mode driver. Again, it's grouped, so we can see there's probably user mode driver, NVOGL shim. Let's just go over here and look at NVOGL shim 64. Go to our buddy, the properties. And what do we have? So this is NVIDIA's OpenGL shim driver. Let's look at the OpenGL, the non-shim. And this is NVIDIA compatible OpenGL ICD. So I kind of have heard about that before. Let's just search Google real quick. All right. So this is the NVIDIA OpenGL installable client driver. And you can see our old friend, the details panel, got us a little more information. All right. We're learning. We're not trying to reverse, really like find bugs yet. We're trying to find that section that we want to really spend time on. So we can look at OpenGL. We know where that is. It's a shim and a driver. Let's look at UMD shim. That's the Direct3D shim. So Direct3D is Microsoft's kind of 3D subsystem. This is probably the direct. Let's see what NVLDUMD is. NVL. Am I missing it? NVLDUMD. Yeah, right here. What is this one? Did we ever look at this one? That's a driver loader. Huh. So there might be a driver loader for the user mode drivers. The shims are interesting. I wonder if there's some kind of shim. I wonder if that's why. Yeah, I don't know. Usually a shim means that there's something pluggable. Like there's something you want to, there's some default and your driver needs to override the default. All right. A lot of the same stuff over and over and over. I don't know what that is. I'm tired of scrolling. It has a different, no, it's the same number. All right, well, all right, what that tells me is those are going to be interesting places to look. I don't think there's anything else really that I'm going to focus on too much right now. There is one thing to explain about drivers. The way that you communicate from the user land to the driver in some cases is called like an ioctl or an IO control packet. And there's handlers inside of this for every type of ioctl. So a lot of times there's a ton of functionality you may want to audit in those IO request packets, IRPs they're called, through these ioctl codes. So we can look at that real quick. We might call it a night. Registry keys are always good because we want to find more readable stuff. NV tweak. What is this? So APIs are, anything that says API sounds interesting. Microsoft makes you do a ton of stuff before you allocate a string, Unicode string. I'm looking for things that might make sense. Not, what is, you know, any of this kind of thing. So they've got a memory allocator class, and I might be in the memory allocator. I don't know. Who knows where I'm at? There's a new constant called NVIDIA AL. Huh. Let's look at, so that was definitely, the NV API is definitely a path. Let's look at one thing. Let's go back to the tools. WinObject is really good at doing this. So this is all the different namespaces, and it includes your devices. Your devices can create different devices, symbolic links. So I just want to see if there's an NV API. Oh, there's an NV admin device. What is that? That sounds cool. NV admin device. I don't know. Is it in the global namespace? Let's find. That might just be because of luck. This is an event. That's not that interesting. Let's look at the registry. Let that go. Hello, search again. F3. F3, buddy. I did install this the other night. Insight Visual Studio Edition. I don't know how I got this, but okay, we're gonna keep this open. Actually, I'm gonna post this path. That sounds cool. I'll post this in Discord. I will keep, I don't want to keep searching too long. It's kind of boring. But this to me is very interesting. So to define a string is A, but if it's a wide character, then you've got to do that thing I showed you earlier. And please, if someone knows the hotkey for that, I might set one up. But see, here's another one. One thing that we'll do in a later episode is I'll show you how to really clean up these type of this binary, this IDB. So you can it'll misidentify it as some kind of XMM thing, but it's really just a it's really just a string. So okay. If anybody has any questions on Discord, let me know. We'll call this episode done. Like I said, I mean, I'll be doing this every week. I think what we've learned is that we've got a driver. The driver has maybe an API. The driver loads some shader code. We have a few DLLs that we want to look at. So we want to go look at some of these shims, user mode drivers. We will be able to get through a lot of this pretty quickly, just poking around like I'm doing until we come up with something that's maybe more interesting. I guess the last thing before I go, unless someone has questions, there is so there's a if you look at if you're used to looking at DLLs in the user space, they'll use like a load DLL or something, or a get proc address. And so you'll be able to find like maybe some dynamically resolved or runtime resolved functions. The kernel has the same thing, and it's this get system routine address. So if sometimes you can find maybe some interesting stuff here. See, we've got a broken, IDA just doesn't do well with Unicode. So here's some more functions that may be interesting. These are dynamically resolved, and perhaps they come from the GPU manager. I don't know. But that's another little tip. You can see there's 48 of these. WMI. So anyways, this will usually take a handle to the driver or something. Sometimes I might pop into GraphView. Look at how ugly this is. See, if I see this, then I freak out. But if I'm just back in here, then I don't freak out. Because I don't know how much information it is. All right. All right, everyone. I showed y'all some tools. Showed you how I start that from the very, very start. Some of this is really fun. There's a lot to look at. I'm just popping up a JSON file that they have here. Who knows what this is? It's Optimus layer. I don't know. Whatever. We have a lot of work ahead of us, but tune in next time and join Discord. I'll probably like read up on some stuff. I'm not going to do a lot of stuff that I think you'll want to watch, but I'll probably read up, and if if it's relevant, I'll post it in the Discord. But if anybody else wants to look at shader languages or kernel stuff or whatever, post it in the Discord, because we're all kind of learning this together, and this is all new for everybody. If you have a particular skill that could help us get through this faster, then that's what the Discord server is for. So I appreciate it to anybody that tuned in. Thanks a lot. We'll do this again next Thursday, 8 p.m. Central, and then I'll upload the recordings. But I hope you learned something. Get on the Discord. We can chat. Okay. Thanks, everybody. See ya.